So here's how to balance that using the half reaction method under acidic conditions. Okay, so the steps for this method are kind of similar to what we did before. So first we want to assign the oxidation states for each atom, but then this time we're going to write half reactions, and that's just going to show which atoms are involved in the reduction and which ones are involved in the oxidation. And then within each of those half reactions, we're first going to balance all elements except H and O, just by using inspection like we're used to. Then, to balance the oxygen, we're going to add the appropriate numbers of water to the opposite side. Then to balance the hydrogen, we're going to add a proton, so just an H plus to the appropriate side. And then we're going to add electrons to balance the charge. And remember, in reduction, the electrons will be on the side of the reactants, but in oxidation, they'll be on the side of the products because they're being lost. Okay, and then here's what's really important. We have to multiply the half reactions by whatever integer is appropriate in order to make the number of electrons equal for each. And then at the end, we can just add our half reactions together and cancel identical species. So let's get started. So first, let's assign oxidation states. So again, we typically want to start with oxygen and hydrogen if we have it. So let's start with oxygen here. So oxygen has an oxidation state of -2. But here there are 4 of them, so this total kind of part right here has -8. But if you all will notice, this MnO4 is not neutral. It has a negative charge. So we only need manganese to be +7 here in order to maintain the total -1 charge on our compound. Okay, and so here we have a charged cation, so its oxidation state is simply its charge. Here we have another charged cation, same thing applies there, +3. And then over here, how nice, another charged cation, +2. Okay, so now we've assigned oxidation states. So now let's write the proper half reactions. So we're going to have our oxidation half reaction, and then our reduction half reaction. Okay, so oxidation, if we'll remember, just write a little note, is when you lose electrons, and reduction is when you gain electrons. Okay, so let's look at our changes in oxidation number. Let's just start from left to right again. So manganese, it starts out a +7 and then goes to a +2. So its oxidation state is becoming less positive. So that means it's gaining electrons. So that's going to be our reduction half reaction. So I'm going to write that down here. So we take our reactant, and it's going to our product. Okay, so now, and again, whatever is being reduced is the oxidant or the oxidizing agent. Okay, so here is our time to go back to the equation and check for our oxidation half reaction. So let's check out iron. Here it starts as a +2, but then goes to a +3. So it's becoming more positive and therefore losing electrons. So that means it's our oxidation half reaction. Alright, so far so good. Okay, so now we need to balance all of the elements except hydrogen and oxygen. Okay, so here we look good, 1 iron, 1 iron. Here we look good as well, 1 manganese, 1 manganese. Alright, so now let's balance our oxygen adding H2O. So here we have 4 oxygens. So So that means we should add 4 waters to the opposite side, because now we have 4 oxygens here and 4 oxygens here. This equation didn't have any, so we're good there. Okay, now let's balance the hydrogens using H+. So here we have 8 hydrogens, so we're going to need to add 8 protons, or H+, to the opposite side. Okay, so now we need to balance the charges with electrons. And so remember, we kind of read our hints over here, so our equation should help us. But for oxidation, since we're losing electrons, it should be on the product side. And for reduction, since we're gaining electrons, it should be on the reactant side. But let's just check, and then we can use that to double check ourselves at the end. So we have a 2+ charge here and a 3+ charge here. So this side needs to be decreased by a charge of -1 in order to equal. So we'll put 1 negatively charged electron over here. Okay, good. It's on the product side just as we expected. Now let's go to our reduction half reaction. So here we have a charge of +2, and here, wow, all those protons. We have a charge of +8 minus 1, which leaves us with +7. So in order to get +7 down to +2, we need to add 5 electrons. Okay, and good. They're in our reactant side just as expected. Okay, so now we need to check and see if the number of electrons in both of our half reactions are equal. In this case, they're not, because here we have 1 electron and here we have 5, and that's a problem. So what is something we can multiply both of these by to get to the same number? Well, it happens to be nice because 1 is easy. We can just multiply this by 5, and that will get us 5 electrons. So this whole reaction is going to be multiplied by 5, both the ions and the electrons. Alright, so I'm just going to write out what we have so far for our half reactions one more time, with it multiplied by the appropriate thing, appropriate integer. Alright, so here's our reduction again, making sure to get that coefficient in there. Okay, then I'm going to write this 5 electrons first, plus 8 H plus MnO4 minus. Okay, so we did that. So now it's time to add the half reactions and cancel identical species. So, like good old days, going to draw a line so we can add. And so, our electrons are going to cancel. So you can cancel whatever's on the product side with whatever's on the reactant side if they're the same. So 5 electrons cancels with 5 electrons, and nothing else will cancel. So that leaves our final reaction being 5Fe2 plus aqueous plus MnO4 minus aqueous plus 8H plus, and those will be aqueous too, they're just floating around in the solution. Fe3 plus aqueous plus Mn2 plus aqueous plus 4H2O. Okay, try to get that where y'all can see it. Okay, and if we were to look at this now on that bottom equation by inspection, it should still balance as well. Have 5 irons, and so forth. So both the charges and the atoms should still balance. So if you get down at the end and you're checking your work and something doesn't balance like normal, then you know you've messed up somewhere and need to go back. So I guess I should add another step. Check your work. Alright, but that's how to balance using the half reaction method in acidic conditions. And I'm sorry I forgot to point this out, but it will always be specified on the problem when they want you to balance. If it's when they want you to balance in acidic conditions or in basic conditions. So sometimes they'll write it right over the arrow, sometimes they'll write it in parentheses to the side, but just make sure you're watching out for that. Alright, so now we're going to go on to balancing half reactions in basic conditions. That's what we'll pick up with next.